Hello everyone, in this video we're going to be looking at operating system concept sample questions part 3. Question 1a. Briefly explain the role of operating system in the computer system. As a programmer, understanding how operating system works may help to create a usable app across different platforms. Simply because as almost all code runs on top of an operating system, knowledge of how operating systems work is crucial to proper, efficient, effective, and secure programming. Understanding the fundamentals of operating systems, how they drive computer hardware, and what they provide to applications is not only essential to those who program them, but also highly useful to those who write programs on them and use them. Question 1b. Elaborate on the point that resource allocation is one of the important services provided by the operating system. Running process requires resources. When there are multiple processes running at the same time, resources must be allocated to each of them. The operating system manages different types of resources. Question 1c. What will happen when the process is allocated with a CPU core and is executing? You may answer any one of the following. The process could issue an input-output request and then be placed in an input-output wait queue. The process could create a new child process and then be placed in a wait queue while it awaits the child's termination. The process could be removed forcibly from the core as a result of an interrupt or having its time slice expire and be put back in the ready queue. Question 2a. How is Thread supporting the multi-core processor architecture? In multi-core processors, a mechanism to exploit the core's proximity and allow fast communications between cores is needed. At the hardware level, thread communications depend on cache coherence mechanisms, resulting in demand-based data transfers. Question 2b. Describe the CPU scheduling optimization criteria. To maximize throughput and CPU utilization, to minimize turnaround time, response time, and waiting time. Question 3a. Suppose a system is using the round-robin quantum 20 milliseconds scheduling algorithm. The list of processes, its burst time and arrival time is given in Table 1. The question is, draw an appropriate Gantt chart to illustrate the execution of the processes. As you can see below, this is the Gantt chart. The next question, number 2. Calculate the average waiting time for all processes. This is how you can calculate the waiting time by putting it in a table, and the answer is 27.6 milliseconds. Number 3. What is the effect of reducing the time quantum to a very small number for round-robin scheduling? If time quantum is too small, it causes unnecessarily frequent context switch, leading to more overheads resulting in less throughput. Question 4a. Define critical section. A program segment where only one process can be in the critical section at any given time. A code segment that accesses shared variables and has to be executed as an atomic section. Question 4b. Discuss 2 requirements for solution of critical section. You may answer any 2 of the following. Mutual exclusion. Requirements for solution of critical section. Progress. If no processes are running in the critical section and others are waiting outside the critical section, only those processes that aren't running in their remainder portion can decide on which processes should run in the critical section next, and the decision cannot be postponed forever. Bounded waiting. After a process has made a request to access its critical section, and before that request is approved, a limit on the number of times other processes are allowed to enter their critical sections must exist. Question 4c. What is a semaphore? By using the following figure 1, explain how it may relate to a semaphore. Semaphore is a synchronization tool used to control access to a common resource by multiple processes in a concurrent system. A variable. A semaphore is a signaling mechanism, and a thread that is waiting on a semaphore can be signaled by another thread. Imagine a set of waiting threads lined up in a queue. Much like a lineup in front of a busy restaurant, a semaphore is like a security officer at the front of the lineup. It only allows threads to proceed when instructed to do so. Semaphore consists of wait and signal method. Let's say this situation is occurring at a restaurant that has a limited access number of customers due to the COVID-19 pandemic. The security officer guards in front of the restaurant's door to control the movement of customers. When the number of customers in the restaurant has reached the limit, it will execute wait method so that the people outside the restaurant cannot enter the restaurant. Therefore, there are people waiting. Once the customers inside the restaurant have done eating, they will leave the restaurant and execute signal method to alert the security officer that there is an empty space in the restaurant. Security guard allows the people who are waiting to enter the restaurant. This concept is similar to what happens to the processes. The wait method is executed when the number of processes in have reached the limit, and the signal method is executed when there is or are empty space. Question 5a. Briefly explain the role of the operating system in the computer system. The operating system manages all of the software and hardware on the computer. It performs basic tasks such as file, memory, and process management, handling input and output, and controlling peripheral devices such as disks, drives, and printers. Question 5b. We want the programs and data to reside in the main memory permanently. However, this is not possible. Why? The answer is, main memory is usually too small to store all needed programs and data permanently. Main memory is a volatile storage device that loses its contents when power is turned off. Question 6a. Elaborate on the point that program execution is one of the important services provided by the operating system. The answer is, the system must be able to load a program into memory and run that program. The program must be able to end its execution either normally or abnormally by indicating error. Question 6b. Explain one benefit of using application programming interface rather than a direct system call. Give one example of a system call to control processes. You may answer any one of the following. Program portability. The program can be compiled and run on any system that supports the same application programming interface. And actual system calls are usually more detailed and difficult to work with. One example of the system calls to control processes is load, execute, or create process, terminate process, or wait for time, or allocate and free memory. Question 7a. One of the services provided by the operating system is file system manipulation. Briefly describe what does it do. The answer is, operating system allows users to read, write files and directories, create, delete, search, list, access permission, etc. Everything is kept in a file. Question 8a. Describe the CPU scheduling optimization criteria. To maximize throughput and CPU utilization, minimize turnaround time, response time, and waiting. Question 8b. Suppose a system is using the shortest remaining time first scheduling algorithm. The list of processes is burst time and arrival time is given in Table 1. Number 1. Draw an appropriate Gantt chart to illustrate the execution of the processes. Number 2. Calculate the average waiting time for all processes. You may put the calculation in a table like you can see below. Number 3. What is the real difficulty with shortest job first, and how can we overcome the difficulty? The answer is, the real difficulty with the shortest job first algorithm is knowing the length of the next CPU request. For long-term job scheduling in a batch system, we can use as the length the process time limit that a user specifies when he submits the job. Thus, users are motivated to estimate the process time limit accurately, since a lower value may mean faster response. Question 9a. Memory is central to the operation of a modern computer system. Explain the above statement. The CPU can load instructions only from memory, so any programs to run must be stored there. A process must be in memory to be executed. Question 9b. Why do processes need to have separate memory space? The answer is to protect user processes from one another, to ensure correct operation, and to ensure that the process can only access the dedicated addresses that have been allocated to them. Question 9c. Memory space is limited. A process must be in memory to be executed. How swapping can help in such situation? Give one example to support your answer. A process can be swapped temporarily out of memory to a backing store and then brought back into memory for continued execution. For example, assume a multi-programming environment with a round-robin scheduling algorithm. When a quantum expires, the memory manager will start to swap out the process that just finished and to swap another process into the memory space that has been freed. Question 9d. Given the following information, assume that the processes arrived in the following sequence: process A, process B, process C, process D, and process E. Answer the following questions. Number 1. How worst fit algorithm is implemented? The answer is allocate the largest partition. Must search the entire list. Number 2. Use the worst fit algorithm to allocate memory blocks to the arriving processes. Process D and process E need to wait. Number 3. State one advantage of worst fit algorithm. It produces the largest leftover whole, which may be more useful and could be allocated to other processes. Number 10a. Answer the following question about page fault. Number 1. Under what circumstances do page faults occur? The answer is page faults occur when a process tries to access a page that was not brought into memory, a page marked invalid in the page table. Number 2. Describe the step-by-step actions taken by the operating system when a page fault occurs. Number 1. We check an internal table for this process to determine whether the reference was a valid or an invalid memory. Number 2. If the reference was invalid, we terminate the process. If it was valid, but we have not yet brought in that page, we now page it in. Number 3. We find a frame. Number 4. We schedule a disk operation to read the desired page into the newly allocated frame. Number 5. When the disk read is complete, we modify the internal table kept with the process and the page table to indicate that the page is now in memory. Number 6. We restart the instruction that was interrupted by the trapped. The process can now access the page as though it had always been in memory. Question 10b. Consider the following page reference string: 723125346771054623001. Assuming demand paging with 3 frames, how many page faults would occur for the following replacement algorithms? Number 1. LRU replacement. The page fault is 18. Number 2. Optimal replacement. Page fault is 13. Question 10c. Segmentation is similar to paging but uses variable-sized pages. Suggest and explain a segment replacement algorithm that could be used whenever a segment fault occur considering the various segment size and minimal fragmentation occurs? The answer is the main consideration is to find a smallest segment that could accommodate the required segment on top of the algorithm. This is to avoid internal fragmentation. Question 10D. Explain why thrashing affects the CPU performance. Well, it seems like the process does not have enough frame to execute, then page fault occurs on the active used pages, causing the process is busy paging rather than executing. Question 11A. How can the processor give commands and data to accomplish an input-output transfer? The controller has one or more registers for data and control signals. The processor communicates with the controller by reading and writing bit patterns in these registers. One of the ways is through the use of special input-output instructions that specify the transfer of a byte or word to an input-output port address. The input-output instruction triggers bus lines to select the proper device and to move bits into or out of a device register. Question 11B. What is the role of operating system in dealing with input-output systems? The role of operating system in dealing with input-output system is to manage and control input-output operations and input-output devices. Input-output devices vary so widely in their function and speed, so we use various methods to control them. Question 11C. An input-output port typically consists of 4 registers. Explain 2 of the registers. Data in is read by the host to get input. Data out is written by the host to send output. Status contains bits that can be read by the host. Control can be written by the host to start a command or to change the mode of the device. Question 11D. How can the operating system be designed so that we can attach new devices to the computer without rewriting the operating system? By using device drivers, which will provide a uniform device access to interface to the input-output subsystems. Question 11E. Direct memory access helps large data transfers. How does direct memory access work? Number 1. The host writes a direct memory access command block into memory. Number 2. This block contains a pointer to the source of a transfer, a pointer to the destination of the transfer, and a count of the number of bytes to be transferred. 3. The CPU writes the address of this command block to the direct memory access controller, then goes on with other work. Number 4. The direct memory access controller proceeds to operate the memory bus directly, placing addresses on the bus to perform transfers without the help of the main CPU. Question 12. How does a tree-structured directory better than the 2 levels directory? The answer is, in tree-structured directory, the path to the file is unique to that particular file. Question 12B. On a multi-user system, file sharing is desirable. Sharing is implemented using protection. Describe how the operating systems provide protection in a file sharing environment. The answer is, access to files can be controlled separately for each type of access. Read, write, execute, append, delete, list directory, and so on. File protection can be provided by access lists, passwords, or other techniques. The file owner can grant access to other users. Question 12C. Discuss the advantage and disadvantages of these various allocation methods: contiguous, linked, and indexed. As you can see in the table below, you can write the answer like this. Question 12D. In your own words, describe what the operating system does in free space management. The answer is, disk space is limited. We need to reuse the space from deleted files for new files if possible. To keep track of free disk space, the system maintains a free space list. It will record all free disk blocks. To create a new file, we need to search the free list for the required amount of space and allocate that space add that space to the new file. The allocated space then will be removed from the free space list. Question 12E. Given is the following free list: 00001111, 001111, 00001111, 01100110001. Show the free space information using linked list. Draw the diagram. You may draw the diagram like this. That's all for this video. Thank you for staying till the end. Bye!